Good morning, Karthik.
Yeah, good morning, Abhishek. How are you?
I am good. How are you?
Yeah, I'm fine. Who else joined the class? Abhishek, Adikai, Dattatreya, Nagaraju, and Rajvire. Okay. So, till now, the topics we covered with Amazon Web Services is one is S3, Simple Storage Service. The other is IAM, Identity and Access Management. Okay. Today, we'll be seeing about VPC. VPC stands for Virtual Private Cloud. It stands for Virtual Private Cloud. This is a service that comes under the category of networking. Okay, what we can do with this VPC is we built LANs, local area networks. We can build the LAN. As I told you that WAN is different and LAN is different, right? LAN is the network, the locally which we built and will communicate with each other. Okay. Similarly, on Amazon Web Services, in order to create a LAN, we use the service called VPC, Virtual Private Cloud. Okay. First, the steps we follow while creating a VPC is create VPC. Second, specify the CIDR range while creating the VPC. What is the CIDR range? CIDR range stands for classless interdomain range. I can also call it as LAN range. I can also call it as LAN range. Assume that I have a requirement. My boss says to create me a LAN of 1000 IPs. So how I create instance, how do I calculate that LAN ranges? Usually I use, there is an online subnet calculator. I use this. Okay, just open the Google and search for online subnet calculator. Okay, now I told you with the help of class C, you can create a maximum of 254 IPs of LAN range. Okay, my requirement is 1000, so I'll go to class B. With the help of class B, the maximum of, here you can see 65,534 IP of LAN range I can create. Okay, or if my requirement is more than 65,000, then I'll go with class A. With class A, I can create like 1 crore 67 lakh 77,214, the maximum of LAN range. That's too much high, right? So for this scenario, I'll go with class B. Okay, on class B, my requirement is 1000. So here I'll search for which is the nearby 1000 value. Here you can see the 1022. Okay, I'll search for 1022. Now as soon as I click on 1022, my LAN range is starts from 172.16.0.1 to 172.16.3.254. Okay, here the mask bits has changed to /22. It means that I'll tell you the starting IP of my LAN range is 172.16.0.1, or here the 0.0. I can represent this entire LAN range as 172.16.0.0/22. That's what /22 here. Mask bits is /22. Okay. Now under this I'll get 1022 IPs. How? You can see that what he's saying here, the LAN range starts from 172.16.0.1 to 172.16.3.254 or 3.255 here. 172.16.0.0 to 172.16.3.255. 172.16.0.0 to 172.16.3.255. Under this, he is giving us 1024 IPs. Let us see. 172.16.0.1, 0.2, like this. It goes to till 0.255. After that, what you'll have, the next IP is 172.16 1.0, right? 1.1, 1.2, like that. It goes to till 1.255. After that, again 172.16 2.0, like that. It goes to till 2.255. Again 3.0 to 3.255. It means that from here 0.255 to 1.255. Okay, I mean, sorry, not 0.255, it's 0.02 172.16 0.255. Here I was getting 256 IPs. Again 172.16 1.255. From here to till the last IP 1.255. Again here I was getting here 256. Okay, again 2.02 2.255 256. Again 3.02 3.255 256. So that combination of all these four 256 gives me an total of 1024. Are you getting me, guys? So that's the reason I can represent this entire range as 172.16.0.0 slash 22 as per the online subnet calculator. So any doubts on this topic? You can ask me. Should I repeat it once again? You can ask me. Okay, I am repeating it once again. It's very simple. The simplest theme. I don't want to make it very complex, and I don't want to abbreviate all the networking behind topics, and I don't want to make it very complex. Just simple. What I follow is suggesting same to you. I always prefer while creating an online while creating an LAN range, I always prefer this online subnet calculator. Okay, on this online subnet calculator, as soon as I open this, the first thing is, according to my requirement, I choose the classes. Either it is class C, class B, class A. Here our requirement is 1000 IPs. So I cannot create 1000 IPs of LAN range under class C. So I'll go with class B or class A. Either it is possible with class B or even it can possible with class A. But I prefer to go with class B. That is my option. Maybe you want to go with class A. That's your option. Okay. Now here on the host per bits, I'll select nearby value to my requirement. For my requirement, if it is 1000, the 1022 is near. If it is 2000, I'll go with 2046, whatever it is. It's like you cannot create, hey Karthik, can you create me a LAN range of just 7500 IPs? No, boss, it is not possible. If you want a LAN range of 7500 IPs, you create a LAN range of 8190. Okay, under that you utilize just 7500 IPs. I have to choose nearby value. Now I'll choose 1022. As soon as I choose 1022, the second step I'll represent it with 172.16.0.0/22. That's what I'll provide as my CIDR range to my VPC while creating the LAN. Create VPC. specify CIDR or LAN range. Okay, now next creating of VPC is done. In our example, we have taken an example of 172.16.0.0/22. Now, after creating this VPC, you have to divide this entire VPC into subnets. Okay, what are the subnets? Subnets are like virtual LANs within the LAN. Let me tell you the concept. Assume that you have a LAN. Assume that this box has the LAN you have created. Okay, this is the entire LAN range. If you want, you can divide this entire LAN range into maximum 4 subnets. 172.16.0.x, 172.16.1.x, 172.16.2.x, 172.16 and 3.x. X is a variable that varies between 0 to 255. Why I can create maximum 4 subnets? Because when you see the entire LAN range, okay, here out of this entire LAN range, here you can see that here 0.x, 1.x, 2.x, and then last is 3.255. It means that it is varying from 3.0 to 3.255 also. That's the reason I can create a maximum of 4 subnets. The subnet, we call this as subnets. The subnets least value, the least IP address that you can create is minimum of 255 IPs. You can create a subnet the minimum of 255 IPs. Okay, this is how you can divide the entire this LAN range into maximum 4 subnets. Assume that you don't want 4 subnets, but you want to divide this entire LAN range into 2 subnets, just only 2 subnets. In this scenario, I can go like this is my LAN. But what is my LAN CID here? Here 172.16.0.02, 172.16.3.255. But my requirement is I have to create a subnet of 2, just 2. Subnet 1 and subnet 2. Under this LAN range, how many IPs I was getting? 1024. 1024 means I can divide by 2, means 512 IPs for one subnet and 512 IPs for one other subnet. It's like I can divide 172.16.0.x, 172.16.1.x for this subnet, 172.16.2.x and 172.16.3.x for this subnet. Okay, here I was dividing entire 1024 IPs into 2 small pieces. If I say 512, how I represent this in a CIDR or format, the way we have represented in LAN range, right? It's like 172.16.0.0/22. Here I can represent it as 172.16.0.0/23. The first IP of this subnet. What is the subnet first IP? 172.16.0.0/23. 23 has to give this value of 512. How? There is a formula called 2 power n minus 2. Okay, 2 power n minus 2. Guys, I was trying to explain you a formula that is very uh, technical one. Okay, usually on the institutes, people what they do is for explaining this formula to these people, for that they'll take entire 1 week of classes. Okay, it's very easy. Listen carefully. On the networking class, we talked about IPv4 version, right? Okay, on the IPv4 version, you'll have four different variables: x dot x dot x dot x. Okay, it means that four dots. Sorry, four different things. So the entire IPv4 range is 0 dot 0 dot 0 dot 0 to 255 dot 255 dot 255 dot 255. This is the entire IP version 4 range. Out of this, okay, we can use only class A or class B or class C private IPs. What are the private IPs? In class A, it is 10.0.0.0 to 10.255.255.255. This is the private range of class A. In class B, 172.16.0.0 to 172.32.255.255. In class C, 192.168.0.0 to 192.168.255.255 or 0.255, 255.255. Okay, these are private ranges of class A, class B, and class C, by which we can create LAN ranges. This is how the online subnet calculator is showing. Whenever you go to class C, it is changing to 192.168.0.0. When you go to class B, it is going 172.16.0.0. Class C at 10.0.0.0. Right? This is, you have to by heart these values. You have to remember this. Okay. Now, what I am trying to do is, I am trying to create a LAN. What is this? I am trying to create this OneNote. I hate this OneNote actually. Whenever we see, whenever I say x dot x dot x dot x, okay, in each every x you'll have 8 bits, 8 bits, 8 bits, 8 bits. Okay. Now all this combination of 8 bits plus 8 bits plus 8 bits plus 8 bits forms 32 bits. So here on our requirement 512 IPs, I said it's slash 23, right? There is a formula 2 power n minus 2. So n is nothing but a value of this entire 32 bits of minus 23, the slash 23, or the subnet mask, or that I represent. What is this? 9. Okay. What is the 2 power 9? 5, 12. Okay. This is what, that's the reason I represented as slash 23 in above scenario. Here I represented, that's the reason slash 23. Slash 23 means 512. Okay. 2 power n minus 2. The formula is, okay, n is nothing but 32, the maximum bits minus the value I have given here, 23 is equal to 9. So it is 2 power 9. 2 power 9 is not 512. Why minus 2? The minus 2 I have given it for because on every subnet or the entire every LAN range, you cannot use the first and the last IP, because first IP is used to represent the LAN range and the last IP is used for broadcasting any messages in all over the LAN. Okay, now here, that's while creating a VPC, you have to specify your LAN range, and then you have to divide that entire LAN range into small pieces called subnets. Specify CIDR LAN range. Third, divide the entire VPC into subnets. Okay, subnets apostrophe s. Okay, how? By specify CIDR or range of subnets. Okay, if I represent the same thing in diagrammatical form, this is what we did. VPC, again under the VPC we are creating two subnets. I'll name it as subnet 1, other as subnet 2. The range of VPC is 172.16.0.0/22. The range of subnet 1 is 172.16.0.0/23, and the other is 172.16.2.0/23. Okay, any doubts on this topic, guys?
Karthik,
Yes.
hello. Yeah, Karthik, can you please repeat that 2 power n minus 2 that concept again? Actually, I missed it.
Okay.
Yeah.
On IPv4 version, you'll have 4 variables, right? X dot x dot x dot x. Okay, it means that every x will have on the back end 8 bits. What are bits? 0 or 1, we call it as bits, right? Binary is like, when I say 8 bits, it may be all zeros. Okay, what is this value represents? It represents that 0.0.0.0. Guys, one way of reading the numbers is 1, 2, 3, 4, 5, 6, 7, 8. The other way is in Roman numbers. 1, 2, 3, 4, 5, 6, right? The other way is in decimals like 0, 0, 0, 1, you'll call it as 1, 2, 1, 0, 3, 1, 1, something like it 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 1, sorry, 1, double 0, 1, 0, 1, 1, 0. Do you know this thing? I hope everybody knows this reading of this in these digits.
Yes, Karthik.
Okay, so here that's what I'm saying. So every x represents variation from, it will have 8 bits, 1, 2, 3. It means that x dot x dot x dot x will have again 8 x's in one bit. The x's may be all 0 or it may be all ones of 8. Okay, when you say the IP address 2.3.4.6, so this is in numbers you are saying. Okay, when you convert the same into decimals, this is like, what is that? 1, 2, 3, 4, 5, 6. We have 8, right? The last two. 1, 0. Okay, and 3. 1, 2, 3, 4, 5, 6. 1, 1. Is that right?
Yes, Karthik.
Okay. Now the 4 can be written as 1, 2, 3, 4, 5, 1, double 0. And the 6 can be written as 1, 2, 3, 4, 5, 1, 1, 0. Okay, it means that this entire excess of IPv4 can vary from 0, all zeros to all ones. What is means of all ones? The all one represents 255 or 256. Okay, all 8, when you convert it into numbers here, 1, 2, 3, 4, 5, 6, 7, 8, it represents 256. Okay, all zeros 1, 2, 3, 4, 5, 6, 7, 8 represents 0. Okay, now like this on IPv4 we have 4 x's of 8 bits, 8 bits, 8 bits, 8 bits. Adding all these 4 different 8s gives you an 32 bit, right? Now in the formula 2 power n minus 2, n is nothing but, okay, 32, the maximum bit minus, okay, again we call it as in the entire range we call host side bits and network side bits. Let me tell you what is this host side bits and network side bits. I am not explaining this because I don't want to mess up with going deep and making you think little bit more. Okay, but you are asking, that's the reason I am telling you. Usually this topic takes it has to be teach in a particular way that there is a standard for teaching it. Like first we start with what is IP addresses, then we start with how do you represent the IP addresses. Okay, then we start with network subnet mask, then we go to subnet bits. Okay, then we'll say how to calculate the subnet range. That is, I'm not teaching here any network class here, guys. That's the reason I given you a very shortcut by showing this on online subnet calculator. Okay, but I'm telling you, just I'm explaining you on every CIDR range or the LAN range. Okay, you'll have network side bits and host side bits. I could have written this like this also. Host side bits and network side bits. But this is wrong. You have to write like this only. Why? Because if you see, I'll take an example of class C range 192.168.0.0/24. It means that this entire range represents 192.168.0.02. Maximum it can go 192.168.0.255. On this entire range, you can see that only this last X is varying. Last 8 bits are varying. Okay, we call this last 8 bits as host side bits, and 192.168.0 are always stable. We call that stable bit as network side bits. That's the reason always network side bits would be on the left side and the host side bits would be on the right side. Always host side bits varies on the LAN range. Are you getting me, guys?
Yeah, bro.
Yes, Karthik.
Okay, this is about Adhika and Nagaraju because Nagaraju has did CCNA. He know some networking concepts, and Adhika was into networking. He know that. What about others? Raj, Vinay, especially, and Abhishek, and the two.
I have knowledge on the IP addresses, Karthik.
Okay,
I
that's
had a
good.
course in my master's.
And what about Raj?
Yeah, got it, Karthik.
Okay, that's good. If everyone is okay, see what. So what happens in usually on classes, some freshers may come, some people new to this networking concepts they'll come. If I start teaching all this, they'll get confused. Hey, this is not my subject. I think I'm not going to make this course. They'll think and they'll leave in the middle of the course. So I fear myself like losing a student when I start digging deeper on this networking subject. Okay, that's the reason I'll show you in the simplest way. Boss, use this Subnet online calculator. Just that's it. Okay. Now coming back to our topic, the VPC creations and everything. Where are we? Where are we? Okay. I'll take a new page once again. Create VPC. Specify VPC range. Third, create subnets in VPC. Fourth, specify subnets range. Okay, these 4 steps, when I represent in a diagrammatic form, this is what. Sorry, it's not 0. Here it has to be 3.0/23 because 3.0/23 means 172.16.0.0 to it's 1.255. After that you'll have 2, right? It is 2. 2.02 slash means 172.16.2.02. It will go till 3.255 of 512 IPs. 512 IPs. Okay, we call it as subnet 1, subnet 2. Very good. We created a VPC and we have divided that into 2 subnets. Now, how can these subnets can communicate with each other? For that reason, okay, whatever the computers you launch under the subnet, you have to someone has to provide the IP addresses for that computer, right? Who is that someone? What is the device on the networking that provides the IP addresses and takes care of controlling all this? Router. So I'll attach the router here. This is router. Okay. Now you have to attach your subnets to your router. You have to attach your subnets to your router. Okay. Now on the router, you have to write. Okay, I'll write this step also. Fifth, create router. Sixth, attach router to VPC. Seventh, attach VPC's subnets. Under that VPC, whatever the subnets you'll have, you have to attach VPC subnets to router. Create router, attach router to VPC. Not only attach VPC to router, but also the subnets in the VPC also has to be attached to that router. Okay, created a router and attach it to this VPC, and I have attached all the subnets to this router. Next, on the back end of the router, you have to write route rules. What does that route rules represents? Either whatever the servers that I launch under this subnet can communicate with over other subnet or not. If I don't want the subnet 1 instances or servers, I don't want to communicate with subnet 2 instances, yeah, even I can write a route rule for that also. If I want all the subnets within that VPC to communicate with each other, yeah, I can write a route rule. Okay, it means that you can restrict the computers within the subnet only to communicate with each other within the subnet, or you can make the entire subnet to communicate with other subnet also. Everything will be written on the route rules of the router. How whenever you send a packet, okay, from the computer of subnet 1, it goes to your router. From then the router sends it to the other subnet's computer. What if I return the rule, hey, block this communication? No, then your router doesn't send that information. That's the reason your computer cannot communicate with the other subnet's computer. Everything will be decided by route rules. That's the reason I'll add one more step here. Either create or write route rules. So is that clear, guys? All the 8 steps. Okay.
Bro, explain the last step again, bro. Route rules.
What are routers route rules? What they do? On the router route rules, you'll write a rule saying that whether all the computers of the subnet can communicate with each other, or you want to restrict only the subnet within the computers in the subnet can communicate only with them. If I say, okay, I'll take another example, in deep example, and I'll explain you. One 172.16.0.0/22. 172.16.0.0/23. 172.16.2.0/23. there is a router connected to both this subnet 2 and subnet 1. On the router, I am writing a route rules like serial number 1, route rule 1, 172.16.0.0/23 can communicate to 172.16.20.0/23. It means that all the computers within this can communicate to within this computer. Okay. Or I can say represent this rule as 172.16.0.0/22. It means that, hey, whatever all the subnets within my VPC can communicate with each other. Okay, that's it. Or if I write a route rule like 172.16.0.0/23, that's it. It means that these computers can communicate with only them. And I'll write another rule 172.16.2.0/23. It means that only these computers can communicate with them. Okay, if I erase this entire rule and write a single rule 172.16.0.0/22, then all the computers of subnets can communicate with each other. Is that clear?
Yes, bro.
Now, let us see how do we create and how do we route the rules and everything on Amazon console. Sign into console. Under this category, networking and content delivery, this is a category that talks about all the networking concepts and content delivery concepts. Under this, here you can find VPC. Okay, just click on that. Now, whatever the VPCs that you create, those will be created only on one region. In Amazon, you have a lot of regions, right? On this global infrastructure, you have different regions: India, Mumbai, Singapore, Sydney. Okay, so whatever the VPC you create, this VPCs will be created within the region. Okay, that's the reason I told you when we talk about particular region, Mumbai, on Mumbai region, you'll have availability zones. Availability zones are physical building blocks that are separated from each other, some hundreds of kilometers. Right now, whatever the VPC you create, the VPC you'll be creating on that entire Mumbai region. But the subnet you create, you have to create that subnet to on one availability zone. In Mumbai, I have two availability zones. That's the reason I am attaching one subnet availability zone. Sorry, I am attaching one subnet to one availability zone and the other subnet to another availability zone. But VPC I was creating all over the Mumbai. and the entire Mumbai data center. Is that clear, guys?
Can you repeat again?
Yes.
Every region will have multiple availability zones. Okay, you create VPC in entire region, and you have to, under VPC you'll create subnets, right? The subnets you create on one availability zone. Okay, talking about example, Mumbai. In Mumbai data center, he has two availability zones, AZ1, AZ2. Now the VPC you can create is on entire Mumbai region, but the subnets that you create is in one availability zone S1, in another availability zone S2. Is that clear? Any doubts on this?
No.
Yeah. Now, while creating this VPC, let's see how we create it. This is the dashboard of VPC, how it looks, guys. From here you can see an overview of what is in that. There are two VPCs in the Mumbai region. It means two LANs are created in the Mumbai region. Let me create another LAN. Okay. So how I create? On the left side I go to your VPCs. From here you can click on create VPC. Create VPC and then name that VPC. This name tag is nothing but the sticker I have given, or the name that is giving by me for my remembrance. I can give it anything. Like, and I can give it as my class VPC, or I can say we'll name it as, what we name, test VPC. Okay, test VPC1. I told you while creating the VPC you have to specify the Cidr range. While creating a VPC, specify the VPC range, right? Now here he is asking, hey, what is the range of VPC you want to create? Here let me go with the same example, 172.16.0.0/22. Okay, now if I write something wrong, like I can write 0.0 or like something 0.0/2, it will say it must be valid ADR range, boss. You cannot create anything. Next, our Amazon VPC also supports IPv6, but we are not going with IP6 right now. Okay, next, tenancy. So on the back end, he is creating this VPC on one of the router on his data center. He's asking, boss, do you want me to create? Amazon is asking here, boss, do you want me to create a VPC on my physical device? I mean, separate router, or you want to create a VPC on a software VPC, or like I'll have a one physical device router, under that I'll create virtual VPCs. So it's like shared tenancy or dedicated tenancy. Okay, I always prefer, guys, go with default. Default is nothing but shared tenancy. If you go for dedicated, what Amazon does on his data center, he will have a separate router for you. Okay, that is like 10 times or 20 times cost higher than shared one. Okay, why when we have to go for this dedicated wala, assume that you are a banker or you have your company is some bank company, you don't want to share, you have to be very secure. In that scenario, you go with shared or dedicated. But usually default result does the same thing. We always prefer to go for default. Now I created VPC. Whenever I create VPC, Amazon automatically it will create a router for that also. When you go to route tables, here you can see a router is created for your VPC. See, this is the name. Nothing. I'll name this router as test router 1 because I know this router is created for my VPC. How? When I right side go here, I can see that my VPC name test VPC1. This is what the name we have kept for our VPC, right? When you go back to your VPC, let me explain you this in detail. This is the name that I have given for my remembrance. Even if I want, I can change it. Okay, and this is the unique ID VPC-E9D62881. This is the unique ID given by Amazon for this particular resource of VPC. Okay, for Amazon remembrance, for his remembrance he will give unique ID for each and every resource that we create on AWS. For my remembrance, I'll tag that resource with my names, whatever I want. Okay, now state represents it is everything up and running, everything is good, available. This CADR range represents the entire LAN range of this VPC. Now, what is this DHCP option set? If you create VPC, automatically Amazon on the backend it will create a DHCP server for that VPC. DHCP, what does the DHCP stands for? Dynamic Host Control Protocol. What does that? Let me tell you. These are all computer 1, computer 2, computer 3, computer 4, computer 5, computer 6, LAN, subnet 1, subnet 2. This is your boss router. Now, on router, you'll have a protocol called DHCP, Dynamic Host Control Protocol. I'll write it here. This is one of the networking protocol. What it does is, this protocol will pick the IP address from the LAN range. What is our LAN range? 172.16.0.0 to 172.16.3.255. Out of this entire LAN range, this DHCP will pick one of the IP address. Let us assume that it has picked the IP address of 172.16.1.2. Now it will assign that IP address to your computer. Okay, DHCP protocol will assign IP addresses to the computers in the LAN from the IP range. Okay, whenever I launch a new computer C7, now what my computer does, whenever you power on the computer, it will broadcast a message. Hey, I am looking for IP address. I am looking for IP address. This is how the request reaches to your router, the broadcast message. And the router responds, Okay, in my network, somebody has came new. This C7 computer has came new. Just now it powered on. So it is looking for IP address. So I should give the IP address to him. Now that router will tell the DHCP server, hey DHCP, can you provide an IP address from my range? One of the IP address which is not used by other computers from my range to this newly power on computer. Okay, then DHCP will say, yes boss, it will pick one of the IP address from this entire range which is not used by the other computers, and it will assign that to this newly powered on computer. That is what the purpose of DHCP. Now when you power on this, again this DHCP server will say, okay, this C7 computer has powered off. Okay, now I'll release that IP address from this computer and I'll keep that in the loop. So whenever somebody power on, okay, it will say, okay, now this same address is not used by C7. I'll assign the same address to other computer. This is how DHCP dynamically will provide the IP addresses to the systems of in the LAN. Okay, for that every LAN will have a DHCP server. So here Amazon will also provide a DHCP server for each and every VPC that we create, but we cannot control the DHCP server. Nothing we can do. Amazon is whole responsible for the DHCP server. He will take care of the DHCP server. Okay. Similarly, for each and every VPC, Amazon automatically creates the router also. Okay. This is the ID of the DHCP server, unique ID of the DHCP server that is given by Amazon for this particular VPC DHCP. Now, when it comes to routers, here you can see Amazon has created a router with a unique ID RTB to my test1 VPC. Automatically it created on the backend. Okay. Now I have created VPC. Amazon has created DHCP and router for me for that VPC. Very good. Now I have to create the subnets. Is that clear, guys?
Yes, bro.
Creating VPC is done. Specifying VPC range is done. Now third step is create subnets in VPC. So go to subnets, click on create subnet, and this is my for my remembrance name tag. I can say test case subnet 1. In which VPC you have to create this? In my test VPC. Select test VPC. Here it will list all the VPCs that are available in the region, Mumbai region. Here you can see the Mumbai region. To list all the VPCs available in the region. But you have to select in which subnet in which VPC you are trying to create the subnet. Next, as I told you, you have to attach this subnet to one of the availability zone of the region, right? So here is saying, hey boss, in which region you are trying to create this subnet? AP South 1A or AP South 1B. But guys, these are the names given by Amazon for that particular availability zones. These are the names given by Amazon for their availability zones. It does not change. Okay. Now I can go. I'm creating subnet 1. I'll attach that subnet 1 to my availability zone 1A. Now specify the subnet range. 172.16. What is my subnet range I want to create? One 172.16.0.0/23. 172.16.0.0/23. Now it is accepted. Okay. Yes, create. You can see I have created a subnet, test case subnet 1, and this is the unique ID given by Amazon for that subnet, and it is available, and the subnet is attached to this VPC, test VPC 1. Okay, and the subnet CADR range is, this is what, out of the CADR range I have got 507 IPs. Very good, I can use 507 IPs, and this is I am created this in availability zone 1A, and this is what the router that is attached to the subnet, and I'll tell you what is ACL rules later. Okay, now I have to create another subnet. Similarly, create another subnet. I'll name it as test case subnet 2. In which VPC? Test VPC 1. Okay, maybe you can create this in the same availability zone, or maybe you can create in a different availability zone. This is your wish where you want to create this, but what I prefer is always create subnets in different availability zones, because what if the one availability zone goes down, something happened, earthquake occurred, that entire availability zone goes down, you'll have all your computers within that availability zone, right? Will be lost. That's the reason I prefer, hey boss, keep some computers in one subnet in one availability zone, keep some computers in another subnet in another availability zone. Okay, or I can create it as /24, just 512 IP, 256 IPs. See, now I have 500 IPs with one subnet in availability zone 1A. Okay, I have another 256 IPs created in availability zone 1B. Now I'll create one more subnet. Test case subnet 3. Test case subnet 3. In which VPC? Test 1 VPC. Now here I can choose where. I'll keep it in 1A only. It's my wish where I want to. Now I'll kill Q 172.16.2.0/24. No, it won't take, because hey, your CADR range is overlapping with already another CADR range. Change it. I'll change it with 3.x. Now it will take. I created 3 subnets. Out of 1024 IPs, I have utilized here 500, 250, 250. Done. 1000 is done. Now I cannot create one more subnet, because I utilized all the IPs of my entire VPC. Okay, this is how you create subnets. Is that okay, guys? Any doubts on this topic? Okay, assume everybody is okay. Now we have created VPC, we have created subnets within the VPC, and the router is Amazon already created himself. Very good. Now, okay, that's it for today's class. I don't want to go in detail. Okay, sorry. I want to tell one thing, guys. After creating the router Amazon, we have to attach this subnets to the router, right? That's the reason I kept it here, plus symbol. Okay, we have to attach the subnets to the router. That can be done from, what is our step? Create subnets is done. Specify subnets range is done. Now create router, Amazon did it. Very good. Attach router to VPC. Amazon did it. He already created a router for that VPC only. Next, attach subnets to router. This step we have to do it manually. How? Select the router. Okay. which router here you can select only one router. I'm selecting this one router, and then on the bottom you can see right side Subnets Association. Okay, Subnets Association, click on that. Now here in this entire VPC, in this VPC of the router is attached to this VPC. In this entire VPC, here we have 3 subnets created, right? Test case subnet 1, test case subnet 2, test case subnet 3. I have to attach this to my router. How you can do? Just click on here, edit, and by just clicking on that, you will be attaching. You will be attaching this subnets to your router. Just save it. Now these subnets are attached to your router of VPC. Done. The 7th step is also done. Create route rules. On router, where will route rules will found? Beside the subnet association here. Routes. We can also call route rules as routes. Clicking that here. Amazon has already, click edit. Amazon has already created one route rule. What is that? 172.16.0.0/22. It means that, I told you, right? Every computer within that entire VPC can communicate with each other. Here I told you. 172.16.0.0/22. Router represents all the computers within the VPC can communicate with each other. 172.16.0.0/22. Okay. Now this VPC's computers can be communicated with this VPCs. If you want, no, I don't want this to happen. Yeah, you can change it. Edit, add another rule. Okay, what happened? Why it is not making me to add another rule? There are no internet gateway, network interface, or virtual private gateway targets. Okay, I'll tell you why it is not making. There has to be someone internet gateway. What is this internet gateway? Okay, what is this NAT gateways? What is this elastic IPs endpoints? We'll talk about this on tomorrow's class. Okay, that's it for today, guys. So any doubts on the topic till now we discussed? So I want everyone to create VPCs on your Amazon accounts, create subnets, create route rules, okay, and just try to work around. Tomorrow we'll talk about all these things. By tomorrow end of the day, we will be very good with one LAN created in our own AWS accounts. And day after tomorrow, the next class, we'll launch servers in the LAN, whatever we created. Okay, we'll talk about EC2 service of AWS. EC2 stands for Elastic Cloud Compute. With that service, you will launch or you will create servers. Okay, guys, thank you, and we'll meet up tomorrow. Bye bye.